Hello students, today we're going to learn about percent composition uh, in molecular formulas or chemical formulas. Okay, so how to calculate percentages in the first place? That's what we're going to start with today. And if you look here, we're going to be using this formula the whole time, okay? Where the percentage is going to equal a part divided by the whole times 100. We're going to do a couple of examples right now. Let's say that you correctly answered 24 questions, okay, in in an exam with 34 questions, a 34 question exam. Okay, did you pass? So obviously passing 70% or higher is going to be the percentage. Okay, that's what we're going to look for. The test had 34 questions, that's the whole, but you answered 24 correctly. Okay. Um, So when we do that problem, okay, 24 is the part divided by 34, which is the whole, times 100, okay, is going to equal about 71%. Okay, so yes, you would have passed that exam. Let's do another problem. You need an 81 on the final exam. Okay, so that's going to be our percentage right there. You need an 81. Okay, but the exam has 45 questions. How many questions do you need to answer correctly? Well, you know you need to get an 81. So that's going to be your percentage. Okay, it's going to equal. You don't know the part that you have to get correctly. That's what you're looking for. That's your X. Okay, and you're going to try to answer as many of the 45 questions correctly, of course. Okay, times 100. Well, how are we going to solve for X here? The easiest way is to realize that uh, in order to simplify the top here, you can get X times 100 divided by 45. It's the same thing. Multiply both sides by the reciprocal. Okay, because we always want to do the opposite of what's being done to X. Okay, you're going to get 45 over here and 100. And of course, X is going to equal approximately 37 questions. So you need to get 37 questions on that exam in order to get an 81. Okay, that would give you your 81%. So let's now apply this to chemistry. Okay, what is the percent composition of hydrogen in H2O? Well, when we're asking these questions, we're always talking about mass. Okay, the percent composition of mass. So we have two hydrogens, each with a mass of about 1. Okay, I am doing a little bit of rounding just to simplify the math here, and we're going to get mass of 2 for hydrogen, and we have one oxygen with a mass of 16. Okay, the total mass, or the molar mass, is 18 grams. Okay, 18 grams per mole. So here in this case, our part, we're looking for the percent composition of hydrogen. Okay, so our part is 2, and this is our whole. So 2 divided by 18 is going, times 100, of course, I forgot to write that down, is going to give us about 11.1. Okay, and I'm not doing significant figures here, I'm just showing how to calculate the percentages. Alright, so it's 11.1% is the composition of hydrogen in water. Let's do another problem. What is the percent composition of oxygen in magnesium nitrate? Okay, well the first step here is I'm going to have to find out what the formula of magnesium nitrate is. If you look on your periodic table, you know that the symbol for magnesium is Mg, and since it is on group 2, its oxidation number will be 2 plus. Okay, this is a metal and a non-metal, so this is going to have to be an ionic compound. Nitrate, when you look at the back of your periodic table, is NO3 with a charge of -1. Well, I need 2 nitrates to balance with the charge of magnesium. So the formula is going to be magnesium plus 2 nitrates in parentheses. Okay? So this is the formula right here. Now I got to calculate the molar mass. And I have 1 magnesium with a mass of 24.3. So that's going to be 24.3. I have 2 nitrogens with a mass of about 14. I am rounding, okay, to simplify the math so you can learn. 6 oxygens, with a mass of about 16 each, which is going to be approximately 96. And the total mass, or the whole, will be 148, okay? Again, this is the molar mass, grams per mole. So here, we're looking for oxygen. That's our part, and this is our whole. Okay, so we're going to do 96 divided by 148.3 times 100. I always forget that for some reason. Is going to equal approximately 64.73%. So that's the percent composition of oxygen in magnesium nitrate. Well, let's do a little bit of application, okay? For example, let's say you're eating some salt, okay? And you know, a lot of people worry about sodium. People worry about sodium consumption. So let's just do a simple problem here. How many grams of sodium is there in 25 grams of sodium chloride? Now, obviously, most people don't just go about eating 25 grams of sodium chloride pure, but it is in a lot of food that we eat. Okay, so in order to find out how many grams of sodium we're going to consume in this sample here, okay, we're going to calculate the percent composition of the desired element and apply that percentage to the given mass. So let's work this out here. First of all, let's find the percent composition of sodium. Okay, we have 1 sodium with a mass of 22.99 and 1 chlorine with a mass of 35.45. Obviously, the numbers will be the same. And our answer will be 58.44. Okay, so the percent composition, okay, of sodium is going to be 22.99 divided by 58.44 times 100, and it equals 39.34%. Okay, now I need to apply this percentage into this many grams here. Okay, so in a sample of 25 grams of sodium chloride, how many grams are there of just pure sodium? Okay, that's essentially what this question is asking. So, first thing I'm going to do here is turn this into a decimal. And to turn a percentage into a decimal, you just move the decimal point to the left twice. Okay, and that's a simple thing you can do. And then I'm going to multiply it by the mass. Okay, 25. And my answer is going to be 9.8 grams of sodium. Okay, so in a 25 gram sample of sodium chloride, I have 9.8 grams of sodium. All right, that's it. You can do some practice problems now.